Good afternoon. Building games with Flame. I'm Renan, by the way. I'm Brazilian, and I'm from Porto. I live in Porto, actually, Portugal. And you can find me more information about me on my website there. But also work for Dash Dash. Dash Dash is a startup and has a pretty nice product, which is a Sprite Sheet that connects with everything, like every kind of API you can imagine. It's possible to connect a Sprite Sheet with that. So
hi there, I'm Luan. I'm the original creator of Flame. I'm also from Brazil, like Renan, but I moved to Canada, a city called Kitchener, and I work for Fair, which is a kind of a startup for a marketplace that connect local makers and retailers. And you can also find me on the website or more links at the end. Oops, I think we skipped the slide. So we're talking about building games with Flame, right? So to start, we need to know what is a game. And I think that's kind of a loaded question because like there's some controversy of what exactly is a game or not a game. But we're not going to go to there. We just want to know what is a game in the perspective of a game development. So what does a game have that we need to provide in order to build one?
The first thing I'll have to look into is interaction. What makes a game different from a video or a movie? It's interaction. The user, the player, has to feel in control of everything or some part of the internal world of that game. So user has to feel in control. So for that, user has to. We have to support a lot of kinds of inputs like user gestures and game pads and stuff like that. So in perspective of game development, we have the first part that's interaction, and interaction has to change the player or, depends on the game.
Yeah, so another crucial aspect of game development is that you need some sort of multimedia. So probably your game is going to have graphics, so you need a way to render those graphics. And this could be sprites, could be animations. Also, you're probably, not always, but likely going to have some audio. So you need a way to play background music in your game. You need a way to play sound effects, for example, when the player jumps. And potentially you could have text as well, so you need to be able to render text with custom fonts so that you can have like dialogues or tutorials or things like that.
And also, it's really important to have performance. So everything goes down when user don't feel in control, break it by performance issues. So performance here affects how the quality of your game, how the game is rated on the store or stuff like that. So yeah, this is the third part of what makes a game and perspective of game development. Well,
so you might be saying, oh, all those things, you know, we use them on regular apps, right? So of course your app has some images and text and it has input. So what's the difference? Well, in reality, they're quite similar, right? But I think there's one key difference that we need to understand before we start to delve into game development, and that's the key difference while we're rendering regular apps compared to games. And this difference that regular apps are more of a passive render, while games are actively rendering.
Well, we have our example here. It's a Flutter gallery. I'm pretty sure most of you know. It's our example of a normal app. We have, of course, lots of updates in the screen, scrolls and animations and drags and stuff like that. So we have lots of updates on the pixels in the screen, but kind of different than games because all of those updates are triggered by any kind of event, like a user gesture, a response API, or maybe progress on a call, an API call, or I don't know, Slack and stuff, socket message and stuff like that. So we call this passive UI updates, passive rendering, because it reacts to something, and this is really important because this affects how we write those UIs. Like frameworks like React, Vue, or Flutter widgets are reactive to changes. Like we built reactive Ys for that. Now we have to look into example. That's a game. It's a big UG built with Flame, by the way. This is Flutter running. But I want you to give a look into all updates that exist there, like box glowing, some coins are spinning, and the only input user had there is it keeps pressing, and when it releases, the player jumps, and there's collision boxes and stuff like that. So most updates in the screen are happening because of internal mechanisms of the game, like physics and how the bullets works and stuff like that. And yeah, that's the main difference. And this we call active Y updates because internal calculations of the software produces those UI updates. And of course, we write those Ys differently, and we use something called the game loop.
Yeah, and the game loop is the concept we use to represent that basically the game is running all the time. So the game loop is basically a while true that's going to be running all the time in your game. And the difference is that things are happening regardless of the player. So even if the player is not pressing anything right now, the game loop is running this while true. And there are two main steps that we have in the game loop that are going to be happening all the time, which is the render and the update. And in order to understand those, we must abstract away the state of the game. So the same way you have your Flutter widget and it has a state, you can think of the whole game as a state, which represents a current snapshot of what's going on. So the current position of every character, of the enemy, of the player, their velocities. Maybe you have the player health or XP points, or I don't know, like the number of coins you have. And the render, the same way the build method or the render function react, it's just a function that grabs that state and renders to the screen. So it accepts the state and returns basically an image, which is a frame, a single frame of your game. And the update, on the other hand, is what is going to update your state, and it's going to move it to the next state. Now the key thing here is that update must always take a time, and that is the time since the last update, because this code takes a while to run. And our expectation is that our game is going to run like at a 60 FPS, which is a good standard for a game. And that means that you have a few milliseconds, like let's say 10 milliseconds to do everything. So your update function is going to take in the time since the last one. And basically what it needs to do is to move your state from the state that it was before to the state that it should be after that time. And this is really important to consider because, for example, if you have like a box moving and you wanted to move at a constant speed, so let's say your speed is X, and you must multiply that by this delta time. So every iteration of the game loop, the box might move a different distance because it took a little bit longer. So if your CPU had a lag spike for some reason, you still get a constant move speed. Also here on the loop, we see the player input. So as we said before, the player input is very important because it's a game. The player has to be able to have agency and control the world. So we totally need the input, but the thing is, the loop must run even if the player is not there, because we need to update everything, physics, the world, and the input is just going to be considered in the next update to change stuff that is related to the player, so the stuff that the player can control.
So we have a different way of building Y and a different concept, a different paradigm. So why use Flutter to use games? Flutter good to create games, and the answer is Flutter is perfect for game dev. There's also everything we have. We all know, like the tooling is perfect. We have IDEA, we have debugging. We can deploy, so it's pretty easy to deploy a game on Android, iOS, and other platforms as well. And also, most importantly, we have high performance canvas access. So that's perfect for drawing on the render function. And also, just to clarify, those are those two things that we hook into Flutter to create games. So the update is built is by the schedule frame callback. So this runs before ever frame painting. And there's the render box. So if you were on the Norbert's presentation or on the Rive's presentation, you will know pretty much what those. Actually, we render just like flare those with with the leaf widget, something like that. It's a pretty long name, but it's a leaf, so it doesn't have a child. And we export the game render box, which does the painting of the game. So,
Yeah, and just like that, so I was, starting with Flutter, and this is really cool. I wonder if there's a way to make games because I love games, and I couldn't find anything at the time. So I started to look, and Flutter actually already provides you most of the stuff you need, as we saw in the previous slide. But there are a few rough edges if you want to make your game. So the idea was to build Flame, and it kind of helps you out with utilities that you can use. Like most games are going to share some stuff, and this is kind of the share code that we're going to use. And so I created Flame, and now there's a huge community that's helping out. And you can find it on GitHub. We'll have some more links at the end as well. And yeah, basically I call it a minimalist game engine because it's a lot of tools that you can pick and choose. So it's kind of a modular approach. But before I go too deep into actually explaining Flame, I would like to actually show you how to use it. So now I'm going to ask the live code gods that everything goes right, and we're going to try to showcase that is just to show how easy it is to get started with Flame. And if you have an idea, you can just step right through it. And what we're going to build is this very simple game. So our idea was, you all know Flappy Bird, right? So we're going to build kind of a clone, but just the bird part. So we're not going to do anything more complex than that, like the pipes or anything. But just not to be too boring, our bird, we're going to use this asset that our friend Eric from Brazil made for us. And her name is Ember. And we're going to talk later about what is she a mascot of. But for now, let's dive right through it.
Let's go.
Which one is, yeah, this one. So here we have a sample Flutter project. I went ahead and did some stuff. So in the pub spec, you can see I added the Flame dependency.
Yeah, I can increase the
size
a little bit. Command plus. Whoops. Yes.
Yeah. So I added the Flame dependency. Also added the asset. So the asset, you all know how to do that on regular apps. The only difference that for Flame, it's convention to put inside the images folder because you also have an audio folder for your audio files. And the asset we're using is this one. So you can see it's a sprite sheet because each frame takes a portion of the image. And what Flame is going to do is going to render this as an animation. So each frame, you can see it's a 16 by 16 box here. And this is our little bird animation. Now for the main file, I added some constants here, and we're going to use those later, just so we don't forget. And the main difference is that we have the run app as expected, but instead of having our own widget, like my app or something, I'm actually creating a game which extends this base game class, so that's what Flame provides. And the game gives you the game widget, so that's what we're going to run. And what does this base game class have? Well, basically, you have the render and update methods, as I explained. So, for example, we can override the render method, and we get access to this canvas. So, if you watch the other talks, you know this canvas variable, and you can use it, for example, to draw a rect, which is a rectangle, and we can pass the coordinates. So, let's say I want to draw a rectangle from 0, top can be like 10. Width 200, height 100, and the paint is going to be the color. So we can just create a.
Is that possible to create a little?
Oh yeah, sorry about that. We can. Is this good? The font size?
Is this good?
One more,
folks? Okay.
Yeah. So I can just create a paint. Now, Renan has some pretty good colors, but I don't. So I just choose the color I know by heart.
Oh my God.
Which is magenta.
Oh my eyes.
But that's why we have. Oh, I don't know what's going on here. What?
Oh, ask. Yeah, ask the question for everything.
But I press Shift and it shows the screen.
Oh, sorry.
Well, I just used lowercase, despite not liking this. Yeah, how do you save? This is his computer, so sorry about my. Yeah.
Oh, that's weird.
Yeah, everything I press shows the switch screen.
Go ahead.
Okay.
Oh,
No.
yeah.
How do you? Okay.
All
This
right.
is.
All right.
Yeah. Sorry about that. So there you go. You have a square. So you have the render and update methods, but we're actually not going to use that because we're using the base game class, and basically it has a default implementation for render and update. And what that implementation allows you to do is to split your logic into what we call components. So think of components as kind of widgets. So each component has its own render and update, and we're going to add components to the game, and the base game implementation of render and update just calls those methods. So instead of doing that, I'm going to create a component here. Let's call it background, and it's going to extend the component class, component from flame. And you can see we are obliged to override these two methods, render and update. And our background doesn't change, so we don't actually need to update to implement the update for this one, but we do need the render. And we're going to do the same thing and draw the bracket, but now I want a rectangle for the whole screen, so I need to grab the screen size. So to do that, you might have seen before that I have a size variable here, but I'm not actually going to use that because there's an easier way. So this is the initial size, but if I just use the resizable mixing that Flame provides, you get the up-to-date size. So actually, I don't expect the size of the game to change. Like if it's a mobile game, right, the size of your mobile phone is not going to change. But it's always good to have that in mind. And you can draw rect on the canvas. Draw rect, and we're going to create rect from, and then it's 0, 0, 0, 0. And here it's size.width and size.height. Now the paint, I'm going to create a static constant here because it's never going to change. And paint. And now I'm actually going to use the pretty color that Renan selected for us, so you don't have to hurt your eyes with my magenta. So there's the constant called color.
Thank you, sir.
No problem.
My eyes.
Yeah. Now,
Thank you.
if we rerun, nothing happens because we actually need to add the background to the game, right? So let's add a component, and then when we run, we get the nice background color. And the same way you can build other components. So now let's create a bird component, which is our Flappy Bird. And now we could use component again, and you need to implement the update method to iterate the animation. However, Flame already provides an animation component. And this animation component is going to do everything for us. So you just need to use the correct constructor, which is the sequenced. So sequence is going to extract the animation from an image, which is a sprite sheet, so it has every frame one after the other. Here we have the size we're going to render. So this, we also have a constant, it's called size. So it's a square, size by size. The image path, as I said, by default it's on the images folder, so you just need the file name, which is bird. And the amount is the number of frames, so that is 4, as we remember from the image. And yeah. Also, we need to provide, there's something wrong with our codes, man. Look, it's adding extra codes?
I don't know.
Yeah, sorry.
Yeah.
That's a good catch.
Yeah.
Also, we need to provide the original size in the sprite sheet, so in the texture file. So we need texture width with 16. So we're drawing it bigger than it is originally. And this Flame will use this to split your image. Now, if we add the bird into the game, you see we have it animated and it's running. And
I have to change position.
Thank you. Now, it's not where we want that, because it's like in the corner. So the animation component has all the properties you'd expect. So it has X and Y, and we can just set that to anything, like X equals 10. And it's going to change a tiny bit. But actually, I want to center it. So I'm going to use the resizable again, because I want to grab the screen size so I can center. And I'll actually override the resize method. So that comes from the resizable. And every time it resizes, I'm going to update the size property. I'm also going to recenter. And to recenter, I'll need to do size.width over 2 minus the difference, because the anchor is on the top left So I need to subtract that difference, so it's actually centered. Instead, I'm going to change the anchor to be on the center. So anchor equals anchor.center. And what that does is now the anchor, so by anchor I mean like the reference point in which the x, y is calculated. So now it's the center of the bird. So the x must be the center of the screen, and therefore the bird will be centered. And also the y, the same thing, is going to be the height over 2. And now if we rerun that, now it's on the center. Now, it's still not very fun because, on Flappy Bird, it falls, right? So we need some movement. And to do that, we can have a variable which is the speed in the y direction. Let's start that with 0. And so to do that, we actually need to implement the update method for reals now. And we're going to actually call super. So this is calling the animation update. So that's checking the animation for us. But we need to do more stuff here. Basically, we need to update the y coordinate and also the speed. Because if it's falling, like real life falling, it's falling with constant acceleration, which is the acceleration of gravity, and not with constant speed. So a more naive way to do it would be something like, oh, the y is the speed y times time, right? But this is for constant speed. So if it falls like this, it's going to go down. It doesn't look like it's falling because of our intuition of things that fall with acceleration. So in order to consider acceleration, we have a constant here, which is the gravity. So this would be the gravitational constant, and this is a value we pick that kind of looks good and feels like Flappy Bird. And you can, of course, tinker with that. So the real formula would be the changing position is the speed times the time minus the acceleration, which is gravity, times time squared, which I'm going to do time twice, over 2. So you might remember that formula from your physics class, which I really like physics because I'm a physicist. But you can Google as well if you're regular people. And I also need to update the speed, which is going to increase constantly using the gravity times the time. So this acceleration times the time. Now, just by doing that, you can see it falls, and we can restart, and it falls again. Yeah, I think that's it, right?
I think that's
now
it.
We can switch to,
yeah.
and now it's going to show more cool stuff because it's not very fun yet because you can't actually play. It's just a...
Just look at her falling for her
Forever.
death eternally.
Yeah.
Yeah. One important thing to point is this first parameter that we receive on update. It's the time from the delta time from the last update. So we have this to help us to calculate.
Yeah.
All right. So first of all, I think I'm going to change it from she falling eternally to she coming back to her original position. So I'm going to create a new method here. Okay, I'm going to call reset because it's going to reset stuff. And that's my own keyboard, and we're having difficulty with it. It's okay. Okay, actually, I'm moving. Whoops, yeah. I'm definitely having problems with this. All right. Okay, I'm moving this code right here to reset. Actually, resets also, resize also calls, it calls on the first sizing of this component. So yeah, we can call it like initial state or something like this. So initial values will be like those. And well, if she goes outside the screen, she comes back to the original position. So if y is bigger than height, size height. Yeah. Dot height. Well, we do reset. Control and
Semicolon.
Semicolon. Really? Oh yeah, semicolon. I thought it was the shortcut. Okay. Yeah, and she falls, and she falls, and she falls, and she falls. It keeps accelerating. Yeah, it's nice to see now, but well, let's
to reset the speed, right?
Yeah, and stop her. Yeah, that's it. That's also important. Let's reset the speed. Yeah, you can use this or you cannot. I don't like to use this, so you're gonna have this code here. But it's live coding. It's okay. Yeah. Okay. 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 Now it's better. And she starts to fall again. Right, I think we should give the player some interaction. that's what makes a game. So we already have the assets, we already have the physics from Luan, we have the performance for Flutter. So I think we need a reset for interaction. First thing is like she's frozen, so we create a frozen. Don't need to set it up now, but we create a frozen flag here, and we just set false. Oh, yeah, oh, no, true, sorry. That would look funny. And if she's outside, and resets, and that's update. Okay, oh, she's not frozen. Yeah, because we're still updating. So if we are frozen, let it go. Let it go. Can't hold back anymore. Like frozen, we just return and don't do nothing. Well, yeah, that's it. Now she's frozen forever. I'm gonna add a callback here for OneTap. Actually, it doesn't receive the OneTap directly. We have to call from game, but let's set up now. We can override this method called OnTap, and we can call this method onBird. But first of all, we need to create a reference for bird here. Okay, and bird receives this and this kickstart, and we can call bird. It's on tap. That's it. So, whoopsie. First interaction we have, but still does nothing. So if it is frozen, frozen is false. Okay. Let's update, and whoopsie. Yeah, she starts to fall. So we have interaction. I'm clicking on her, and starts to fall. Okay. I think for this being really a flatbird, I think we have to give the player the opportunity to save her. So on tap, I'm gonna reset her speed. So frozen false and return. So when I'm setting up frozen, I don't want to do anything, but on speed, why? Let's freeze her or something like this, or reset the speed. So yeah, for beginning, it's not gonna do anything. Come on, run.
We should actually set the speed to the variable boost that we have.
Yeah. Just to show off, we are kind of stopping her, so we can just set to boost. All right, and I think we're gonna have a Flappy Bird kind of thing. So I'm clicking and she's going up, starts to fall again, and then we can save her for as long as the user is willing to click on the screen. So when I stop, she keeps falling. But yeah, this is pretty much like Flappy Bird, but I don't find this realistic because, well, she's falling and gets a really fast speed, and then we just reset her speed to back again, and I think it would be better for her if she just hit the floor, but okay. Let's do it based on speed. Why? So we are updating, and it's based on her speed. But this is a problem, because if I click too fast, like I did right now, we send her to space, but we can clamp this speed. And let's see, upper will never happen, but okay. Whoops.
You need just some boost.
All right, yeah, forgot the most important. Yeah. Okay. And she starts to fall, and we.
So now we need to click a few times
to
cancel the downward speed so it starts going up.
Yeah, I think it's a little bit harder than Flappy if it's that possible. Well, yeah, I think that's it.
Yeah.
Now, yeah.
Well, maybe we can do something else fun, which is the angle.
We have time for
So
angle.
in Flappy Bird, you know, the birdie looks in the direction she's going, so that's the direction of her momentum, right? So in order to do that, it's pretty simple. We just need to make a few considerations because in this game, kind of her momentum is always down because it's not really moving forward. So it's either down or up, and that's not very fun. So let's just pretend that she's going forward at a constant speed, which happens in the game. So that will be the speed that the pipes are coming in. And so let's create the actual velocity of the bird, which is the 2D speed. And let's use the position class from Flame, which is a vector. And let's call it speed. And we can create a new position. So for the x, let's suppose it's like 300. So this is just like a fake speed, just so she's not always looking down. And let's also provide the speed y. And we can import this from Flame. And now we just need on the update method to set the angle. So this is also a property of the animation component. So it renders in an angle. And we can use the velocity class, the velocity object that we added, has a method angle in it. I don't know why it's, oh, I called it speed. It's velocity. So understand in English, speed is like the linear and velocity is the 2D part. So this is the actual angle, and we also need to reset the angle in the reset method, otherwise we're going to keep that once it dies. And that is enough to make it fall in an angle. And as we go up, it tilts up and then tilts down.
Yeah, and yeah, I think we have time for showing. First thing, we can show that this is not an emulator. This is running on Flutter desktop, so that's possible to run a Flame on desktop as well. And yeah, I think we can like compose a little bit. Like this is a widget, like anyone else. So we can put this on like a material app, you know. And the material app has a home. Let's go basic here. Scaffold, and there's no body, and we have the game. Oopsie. Oh yeah, there's something wrong here. Yeah, this is running on this scaffold. There's the debug here, but just to clarify, app bar, and text, sorry. Title, text, and, well, something like JavaScript.
I don't endorse that.
And yeah, this is still a game running in the middle of a Flutter app.
Yeah, so that's pretty cool. It's a regular widget, so you can compose inside your apps. And also runs on Mac and web. That's still like beta. We're working on it. So I think the audio players to play audio doesn't work on web yet. I'm still working on that, but it works on Android, iOS, and Mac OS already has the audio players implemented.
Yeah, and games are not only the gaming screen, so you have pause screen that has the menus. So Flutter widgets are perfect for those screens, and you can put, if you want, if it's your case, you can put several games at the same screen if that's viable for you. So yeah, that's it for the demo. Demo is open source as well.
You can find it on GitHub.
Yeah, it's on GitHub for FireSlime.
And a little bit more about Flame. So you guys see how easy it is, but it also provides a lot of other features that we didn't show. And the idea is being like this modular thing that you can pick and choose. So we have the game loop with the component system. You actually don't need to use components if you don't want, so it's all like optional. We have the audio capabilities. So that's through the audio players plugin. You can play like background music, sound effects. We also have lots of ways to render graphics. So we have the canvas access, as you saw, have sprites. We have animations. We also support Flare, so we can add Flare animations to your game. You can add SVG. Also, huge shout out to Ivan, who made the particle accelerator, not accelerator, physics, right? The particle emitter for Flame for us. So he sent a PR, and shout out for him. Yeah. And yeah, there's parallax. So, it's all things you could do yourself, but Flame provides you out of the box, so you can just pick and choose. there are several ways to do inputs. So I got the on tap, as you saw, but there are more complex gesture handling. There is also a separate plugin you can add, which is the Flame gamepad to support like physical gamepads on the cell phone. There are other integrations like Tiled, which is a very famous map editor. So your designer can create the maps and they're just import into your game. Box2D, which is a physics engine. So if you don't like physics that much, what can I do? You can use Box2D, which is a very famous physics engine that exists on a lot of platforms, and also Google Play Games integration.
Well, if you're feeling like trying out Flutter and you are seeking for help or stuck with something, you can reach us out on Discord. Actually, Discord just not just questions and answers. It's like a community, and we talk and we hang out there all the time. So there is a small community that a subset of the Flutter community is on Discord for Fire Slime. Also, if you have any questions, and you can feel free to tag your question with the flame tag, and probably one of the experts like him or me, or no, not me, but them can answer your question. Also, we have our website for documentation. And also, of course, the repository where you can find the source code, and also the most updated documentation on branches or everything that's going around, and some discussions on issues as well. Well, get involved. That's it.
Yeah, and also we briefly mentioned Eric and the Ember thing. So Ember is the logo for Fire Slime. So we have Flame. We built with the community. It's totally free MIT, but we decided to start making some games. So it's kind of our indie like game studio or something. And Eric that made the sprites is in Brazil. Me and Renan, we kind of started building some cool games that we like using Flame. So these are all examples of Flame games. Well, it's kind of cut out a little bit, but the first one is a T-Rex part that Renan made using, so Google Chrome made available the sprites for this game that you all for sure know, and he made a Flame part. Tails is our biggest game we're still developing. It's a very big, complex game, so it shows that we can build big games and we have a very good performance. And the other ones are very simple, like Endless Runner casual games that are all available. Well, they're all available on Android, and Bobbox available on iOS. We haven't had the time to release the other ones on the iOS store because it's a hassle, but it works on iOS. We just need to get Apple to approve our apps.
Besides Tails, everything here is open source as well. So feel free to take this as example for your games.
And yeah, this is Eric.
And this is Eric. This is the guy.
He's gonna hate us, but hopefully you can recognize, like in the photo, you draw a circle to. Yeah. So, any questions?
Hi.
Hi.
Thank you, guys. It's difficult to believe that we can build games in Flutter.
Yeah.
However, the main question, what about production? I've seen your library is still 0 point something, so is it ready for prod, and can we already find some and download games in production? And second question, you run it on desktop, what about web?
Yeah, so let's start with the first question. It started with 0 dot something, it's still 0 dot something, I don't know. 17
right now?
Yeah, but I think it's ready. We have a few games on the store that are working. I don't think we have a gigantic AAA game yet. I mean, especially because it's primarily mobile, so smaller games. I think our biggest game is Tails, which it's almost done. We plan to release it sometime this year, hopefully. And also there's another big game being made by another member of the community. It's called Tom Toads. I think those are the biggest ones, but we have several smaller games working on the store. So I'd say it's production ready, despite the 0 thing.
And regarding the web, we rely on pointing stuff into Canvas. So when you find yourself with lots of components at the same time on the screen, each of those components will be in the end DOM nodes, and this is not the most performatic way. So we have performance problems with the web yet.
Yeah, it works, but it's not the ideal way. So the ideal way would be use Canvas, but the Flutter web implementation is not ready for that yet, I think.
Yeah.
Also, the audio players doesn't work on web yet, but I'm working on that. It should be ready sometime soon.
Okay, cool, thanks.
Hello, thank you for a great talk. And I have a question regarding monetization in the Flutter apps. How should developers approach it to make it successful?
Well, I think that's the same question for any kind of game, right, on mobile. What we've been trying to do, so Bigug has ads, and then you can buy the IAP, the in-app purchase, to disable the ads, which I think is a pretty common way to do it. You can also just straight out sell the game. Or in Tales, what we pretend to do is to have, so you have a demo for Tales of a Lost Mine on the store, on the Android store, you can download it.
You can play right now.
Yeah, and we plan to allow you to play up to the part of the demo that we have so far there. And after that, you have to buy the whole game as in-app. Or you can just, ask for donations, like a buy me a coffee button. I don't know. The same way with any other games that you make, there are several ways to monetize depending on what you want. I don't like microtransactions, though. Don't do that.
Don't do that. Don't do that.
Hey there, thank you so much. This is awesome. One of the other game engines that's out there is Sprite Widget, right?
Yeah.
I was wondering if you guys can just maybe compare and contrast that for us, and if there's anything else out there that, just curious.
Yeah. Can you talk? I didn't look in much
Yeah,
into
so
the
I don't know.
source.
When I started Flame, there were no other options. I heard about Sprite Widget after. I took a look. I don't know exactly how it works, how it compares. I assume it has a similar game loop concept. As I explained, I think that's pretty... Well, some engines might abstract that, but that's very common way of handling things. And yeah, I don't know a lot about it. Maybe...
No, I didn't give a look into source codes of sprites. But yeah.
Okay, so thanks for creating the engine. My question is about performance. So do you have any kind of overlay for frame rates or maybe other statistics, or you rely only on the Flutter frame rate and statistics that they are building?
Yeah, you can use all the Flutter stuff that works really well. So we had some talks in this conference about it. You can use all of that. There are some built-in things on Flame for that. There is a debug mode on Flame that you can turn it on, and it shows a few stuff like FPS, like on the corner of the screen. So there are a few ways you can do that. And as we test with our games, even the most complex one like Tales, it works fairly well on most devices. And in very old devices, sometimes not exactly 60 FPS, but it still runs fine.
Yeah, so that was the second part of the question. Like in the Tales of Lost Mine, do you have like 60 frames per second, or it's like 20, 15?
I think on most devices we reach 60. It runs pretty well. If we use tiled, so we have maps. If your map is way too big, but it might slow down a little bit. But the maps we use, like regular size maps, it's a Metroidvania, so I don't know if you know. Like Super Metroid is so if you have regular size maps, it works pretty well.
Yeah, at the end of the day, it's like works the same way as Flare does with Flare Actor.
Yeah.
Rive does with Flare Actor. It has to be a really, really old phone, a really cheap phone to have a frame drop. We never had this, and the Skia works pretty well, so everything is delegated to Skia. We can rely on that.
Cool, thank you.
Hi guys, thank you for a great presentation. I assume that you wrote some kind of unit test or UI test for your games. Was it difficult to do so?
Yeah, I think it's a bit more challenging than regular apps. So what I do, I normally test like unit stuff. So unit tests. So if you have a little bit more complex logic. So for example, in Tales, we have a cannon. And the cannon fires at the player. So you need to figure out the angle at which the cannon has to rotate in order for the bullet to hit the player where he is. And that was a very complex. So I totally test that. And you can actually test components with regular classes. So you can call update yourself. You can call update a few times, see if the positions match, that kind of stuff. I haven't wrote a lot of real integration tests because you're in the end render pixels to the screen. So that's kind of hard to test. But the actual logic, I think you can use everything that Flutter provides to test your stuff.
Yes. That's it.
Hi. Yeah, thanks very much for the talk. I have a quick question. Perhaps I might have missed it in the code, but for the user interaction, there's an untapped callback that's part of the game class.
So let's dive a little bit deeper into that.
Is it possible to actually get this on a component level?
Yes, we have everything is a mixing, so we have your component, your animators component, something like that, and you can enrich your components with mixings. So we have the tappable mixing that creates those methods like one tap right on the component without having to rely on the games ones. So it's like it hooks on a gesture detector that's wrapping this parent component. So yeah, that's possible.
And you can also add other kinds of detectors. So you have mixins for the game that you can add, like, gesture recognizer, everything that's in there. There's a version on Flame that you can add to the game. Also, you can wrap your game with a gesture recognizer, and that will also work.
Yeah, that will also work.
Cool. Yeah. Thank you.
Hello, thank you for presentation. You've used Joy-Cons on your presentation. Is it some leak or something about Nintendo Switch?
No, no. That was just for a pure...
Okay, and is it possible, like, in our imagination that Flutter will be released on Switch?
That is a dream.
That's a dream. That's something I really try to work on, but it's really hard to get a Nintendo accounts development. It's
kind of closed.
Yeah, it's kind of closed for studios. If you are an indie studio, it's okay. But Fire Slime is not even. It's just registered as a company. So
it's just our hobby.
Yeah, it's just a hobby.
Thank you.
That would be the dream.
Hopefully, Google folks here can maybe help with that.
Yeah, yeah.
I think we have to end now, but feel free to contact us. You can see us in the hallways.
Obrigado.